let us discuss about developing the schedule, and this video is part of the iteration 2 of the PMdistilled PMP Fast Track course at pmri.in. The schedule development comprises of analyzing activity sequences, durations, resources, schedule constraints to create a schedule model. I repeat, schedule development comprises of analyzing activity sequences, durations, resources, schedule constraints to create a schedule model, which is used for project execution and monitoring and controlling. And it provides planned dates for completion of the activities. This process is performed throughout the project. So schedule development is not something that happens only once. It continues throughout the project. In develop schedule, the key processes are schedule network analysis, critical path method, resource optimization, what if scenario analysis, leads and lags, schedule compression, project management information system, which is also known as PMiS in its short form, then Agile release planning and schedule baselining. So develop schedule happens under the planning phase of the project, and the key activities are schedule network analysis, critical path method, resource optimization, what if scenario analysis, leads and lags, schedule compression using fast tracking and crashing, and project management information system, Agile release planning, and schedule baselining. A schedule network analysis, here we have given a sample network. This is an activity on node diagram or a precedence diagramming method, which we discussed in one of the earlier lessons. So here we have the start, and this is activity A, duration is 5 days, activity B, duration is 5 days, activity C, duration 10 days, and activity D, duration 15 days. And we started on day 1 and 5 days duration, so we complete activity A on 5th day, and likewise we do a forward pass and calculate the early start and the early finish. So if activity A is getting over on the 5th day, activity B can start on the 6th day. Duration is 5 days, so it will get over on the 10th day. Now we should do the forward pass for activity C as well. So if this is 5, this will become 6, and the duration of activity C is 10 days. So 10 plus 6 minus 1, that is a short form. So on the 15th day, activity C will get completed. So activity C is getting over on the 15th day, and activity B is getting over on the 10th day. So activity C can start only on the 16th day. And the duration is 15 days, so it gets over on the 30th day. And we do a backward pass, that is 30 gets carried forward here. So if this is 30, this will become 16, and if this is 16, this will become 15, and 15 minus 10 plus 1, that is 15 minus 9, that here it is 6. Whereas in this path, this is 16, so this will become 15, and the duration is 5, so 15 minus 5 plus 1, that is 11. So here it is 6 and here it is 11, so this will be 5. So we did a forward pass and calculated the early start and the early finish. Then we did a backward pass and calculated the late start and late finish. And float is equal to late start minus early start or late finish minus early finish. So we calculate the float for all these things. Activity A 0 float, activity C 0 float, activity D also 0 float, whereas activity B has a 5 days float. So if we connect all the activities whose float is equal to 0, that becomes the critical path. And the critical path is the longest path in the network, or it is the shortest possible time in which the project can be completed. Now additional questions can be, can a project have multiple critical paths? That is quite possible. Now here, if activity B is 10 days duration, then this project has two critical paths, that is ABD becomes a critical path and ACD also becomes a critical path. So technically a project can have multiple critical paths. And if, let's say, if activity B duration is 9 days, then it will have a float of only 1 day. So that means it is very close to the critical path with a float of just 1 day. Such paths we call as near critical paths. So for effective project management, we should not only track the critical paths, but we should track the near critical paths as well. And as the project progresses, this critical path can change based on which activity got completed ahead of schedule and which activities got delayed. So based on that, the critical path can also change. So it is a very dynamic situation, so critical path need to be monitored continuously. The activities on the critical path cannot slip, and if they slip by 1 day, the project will slip by 1 day. So that is very important. So now let us take another network diagram. Here is the start. Here we have activity C, which is 12 days duration, and activity A is also 12 days duration. Without buffer 10 days duration and with buffer 2 days. So there is a buffer for activity A, but still the duration is 12 days. Activity C also duration is 12 days. Now if activity C, if I start on day 1, I can complete it on day 12. Similarly, activity A, if I start on day 1, I can complete it on day 12. Whereas activity B, if I start on day 1, duration is 6 days, I can complete it on the 6th day. So the early start is 1, early finish is 6, late start is 7, and late finish is 12. So float is late start minus early start or late finish minus early finish. So for activity B, it has a float of 6 days. So that means it can float around by 6 days without affecting the end date of the project. Whereas activity A has a 0 float and activity C also has a 0 float. So in this case, this project has two critical paths and one non-critical path. Now let us move on to resource optimization. So at the end of preparation of the schedule network diagram, the next activity is adding resources to it. When we do it for the first time, sometimes you realize that some resources are loaded for 200% of the capacity, whereas some other resources are underloaded. So we have to do a kind of reshuffling of these resources and optimize them, and that process we call it as resource leveling. Because we cannot execute a project with some resources loaded 200%. In this case, Johnny Eager is 200% loaded on Monday and again 200% on Tuesday. So that is not feasible. So we'll have to substitute him with some other resource and ensure that he's not loaded around 100% of the capacity, not to the tune of 200 and stuff like that, because that is not feasible. That process we call it as critical resource leveling. So the next is leads and lags. Next is what if scenario analysis. And while doing the schedule optimization, that means when we do the schedule for the first time, the dates may not be within the required dates. So we have to fine tune it. And one of the tools may be what if scenario analysis. Now, some examples here. Now, instead of normal curing, if we adopt steam curing, what will be the impact on schedule and cost? Because steam curing invites additional cost, but if I'm doing steam curing, the curing time of the concrete can be reduced to 2 days instead of reduced to 8 hours instead of 8 days. So I will gain some schedule advantage. At the same time, it is expensive. So we have to do a what if scenario analysis. If I'm using steam curing, what is the savings on the schedule, and out of that what is the cash cost advantage. But at the same time, by doing curing, I have to invest more. So a what if scenario analysis is required to decide on it. Another scenario, instead of manual testing, if we adopt automated testing, what will be the impact on cost and schedule? So this kind of an analysis we call as what if scenario analysis. And we already discussed about decision trees, and decision trees can be used to perform this what if scenario analysis. Then leads and lags. Now in this case, between task A and task B there is an overlap. So this overlap we call as the lead. Whereas in the second one, between task A and task B, there is a waiting time, or there is a lag. So a lead always compresses the schedule, whereas a lag always stretches or elongates the schedule. An example for a lead can be when the design is 80% completed, I can start with the development work. And an example for lag can be after pouring concrete, I should give 8 days curing time, and only after that I can start with the next activity. So that is an example for lag. Lag elongates the schedule, whereas the lead compresses the schedule. Then comes the we use fast tracking and crashing. So fast tracking is initially we schedule 2 activities like this. First activity should be completed before I start the second activity. Now while fast tracking, I try to do these 2 things in parallel so that my schedule can be compressed. So trying to do things in parallel which were originally scheduled sequentially, we call it as fast tracking. Then we have crashing, because here first activity, after first activity only I can do the second activity. But if we put more resources into these activities, or if we can automate it, or if after doing an alternatives analysis I can find out ways and means of compressing this activity duration, that process we call it as crashing. So after crashing, the duration of the first activity is reduced, the duration of the second activity also is reduced, So overall schedule duration is also reduced. So that is crashing. So in order to achieve the schedule compression, we may do crashing and fast tracking of activities on the critical path so that the schedule duration can be compressed. And the next one is the project management information system. So this is, we are talking about dashboards and stuff like that, which can read out data from different applications like your scheduling system, time accounting system, procurement system, and then risk management system, etc., and show the data in a very presentable ways in the form of dashboards. So we call it as project management information systems, or PMiS. The full form is project management information systems. And the next is an agile release planning. Now our program itself is it goes like iteration 1, iteration 2, iteration 3 to iteration 10. So initially when I planned, I need to decide on the total number of iterations, and each iteration will comprise of how many topics, and which all topics should be first and which all topics should be later. So this process we call it as a release planning. Another example here is we have the total set of features that must be developed, which is known as the product backlog. And now two teams are working here, team 1 and team 2. Team 1 in iteration 1 and in 3 iterations, at the end of 3 iterations or sprints, they'll make a release. And in iteration 1, these are the features they'll develop. In iteration 2, these are the features the team 1 will develop. In iteration 3, these are the features they will develop, and they'll make a release after 3 iterations. Similarly, team 2, these are the features they'll develop in iteration 1, then iteration 2, iteration 3, and they'll make a release after 3 iterations. Then iteration 4 starts, 5 starts, and 6 starts. So we need to do a lot of planning to come out with a scheme like this. That process we call it as agile release planning. We'll talk about this in detail when we reach the agile part of this program, that is in iteration 6 and 7. And once the schedule is prepared, the next thing is baselining the schedule. So once you baseline the schedule, any changes to that schedule must undergo the change management process, like raising a request for change. Then somebody has to approve it. The change has to be incorporated, and it has to be communicated to all the stakeholders concerned. So most of the project management tools have this schedule baselining concept. It is nothing but the version control of the schedule. So with that, we completed the develop schedule process of scheduling. And this video lesson is part of the Project Management Learning Environment of Project Management Research Institute. And if you want to get more details about trainings like this, please visit our website at pmri.in. Thank you very much.